Alright, welcome to Quadratic Inverses Level 2, and at this point we are running into a little bit of an issue. When you look at our example 1, we want to find the inverse function of y equals x squared plus 8x minus 3, and the problem is that this is in standard form, it's no longer in vertex form, so it makes it a little bit trickier initially. In order to solve this, we have to take this from standard form and switch it to vertex form. And so let's go ahead and start. Remember, when finding the inverse of any function, we always start with the exact same step, no matter what it looks like. We'll take our y, and everywhere we see an x, we are going to flip or switch the two things. So we can now write this as x equals y squared plus 8y minus 3. Now we have one more nice easy step, and we always want to get rid of this constant. So let's go ahead and add 3 to both sides. Now, at this point, the x plus 3 can't combine. So we'll write x plus 3 equals, and I'm going to go ahead and circle that zero pair. It's gone. And you'll notice we're left over with y squared plus 8y, and we have no constant here. Well, this is the big idea, and the big trick is that we want to take this formula, b over 2 squared, and we want to create our own perfect constant. Well, what's the b term? Is it the 3, the 1, or the 8? And it turns out it'll always be this 8, this number in front of the variable raised to the first power. So we're going to take 8 over 2 squared, and we know that 8 divided by 2 will give us 4 squared. And what is 4 squared? Well, that's going to be plus 16. But this is algebra, so whatever we do to the right side, well, we're going to have to do to the left. And we can now rewrite this as x plus, let's see, 3 plus 16 would be 19 equals y squared plus 8y plus 16. Now, pay very close attention because this next part is the second, what I'll call the tricky part, is we want to take this right side, y squared plus 8y plus 16, and we are now going to change this so that it becomes vertex form. So I'll kind of write this, parentheses, and we see this y squared, so we have to start this parentheses with y, but we're actually going to move the square up here. And let me go ahead and write the left side. We have that x plus 19. And now the trick is you want to find a number, a constant, that adds with itself to become 8 and multiplies with itself to become 16. Can you think of a number that multiplies with itself to be 16 and adds with itself to be 8? And the answer would be 4. We know that 4 plus 4 gives us 8, and 4 times 4 gives us 16. Now at this point, we actually have a function that is almost the exact same as our level 1 video. So we take a look here, and we notice that we have the y plus 4 squared is all by itself. So to get rid of the square, we take the square root. And now, at this point, we have the square root of x plus 19 equals y plus 4. Now we're one step away, and y'all are pros at this, you know. In order to get rid of this plus 4, we have to subtract 4 from both sides. And remember, I'm always going to rewrite my y as f inverse of x equals the square root of x plus 19, and then outside of that, minus 4. Okay? Alright, pause it, take a second, look over all the things we did, star the points of this where you're a little bit confused, and that way when we go over this second example, you can kind of keep track of, oh, you know, at this step, this is what I want to do. Okay, well, let's take a look at example 2. Now, you'll notice in example 2, it's practically the exact same problem as the last. And whenever finding inverses, what's our first big step? Well, of course, we want to take our x's and y's and switch them. So this now becomes x equals y squared plus 6y plus 2. And from here, well, we have a very, very easy step. We have to get rid of this plus 2 because it's an imperfect constant. So minus 2 minus 2. And like every single other problem, well, can the x minus 2 combine? No. So we'll keep it separate. X minus 2 equals y squared plus 6y. Now notice I kind of rushed a little bit to get to this point, but this is where I'll slow it down because this is where the kind of tricky stuff is. We are looking to create a perfect constant, almost out of thin air, that will allow us to write this right side in vertex form. So how do we find that constant? Think back to the last example. What's the formula that we have to use in this situation? And that's going to be b over 2 squared. Now remember, when looking through this, what's our b term? Where is our b term? And in this case, it's always going to be the number in front of the y, or more generally, we can say the single variable with the exponent of 1. Okay, so let's go ahead and write it. We have 6 over 2 squared. And what's 6 divided by 2? Well, that'll give us 3 squared. And what is 3 squared? Well, we should know this by now. That will be plus 9. But remember, this is algebra. If we add 9 on the right, what do we have to do on the left? We'll add 9, of course. So let's go ahead and write this down. And we now have x, and what's negative 2 plus 9? Let's see, negative 2 plus 9 would be plus 7 equals this y squared plus 6y plus 9. Once again, we're now going to take this side right here, and we want to, let me kind of write it like this time. We want to write this as a perfect square. We do this by kind of always writing this template right here. So let's see, I'll take the x plus 7, and I'll write that on the left. And on the right we have y plus or minus some number. Remember, it has to add with itself to become 6, and it has to multiply with itself to become 9. What number would that be? Well, plus 3. 3 plus 3 is 6, and 3 times 3 is 9. And if you want to know the secret, it's always half of our b term. Remember, 6 divided by 2 will give us that, 3, which will go right there. Now from here, we're just doing the exact same steps that we've been doing since level 1. How do we get rid of the square? Well, we take the square root. What we do to the right, we do to the left. And now we have this. The square root of x plus 7 equals y plus 3. Remember, square roots, squares, they're inverses, they're opposites, they cancel each other out. Our final step, how do you get rid of the plus 3? Well, in this case, minus 3, minus 3. And remember, we like to write our y as f inverse of x equals the square root of x plus 7, make that x a little better, minus 3. And there we go. Alright, go ahead and practice these, and I'll see y'all in our very next video.